Hello and welcome. This recording is session 6 of an 8-part series on the topic Moving Towards Improved Earthquake Performance and Resilience for New Buildings. My name is John Sherstobitoff. I'm a structural engineer focusing on earthquake engineering for buildings. This series of recordings is part of the MBAR initiative by BC Housing. MBAR includes and promotes the consideration of resilience for new buildings for natural disasters such as earthquakes. The list of 8 sessions is noted on this slide for your future reference. Today's session is on post-earthquake habitability. So in previous sessions, we focused a lot on the structural performance of a building, the behavior of the structural system, the means to try and make it perform better than code to a level perhaps of no structural damage. But what the structure supports are all the other aspects of a building to make a building habitable or functional, mechanical, electrical, architectural components, and equipment. So what are the specific requirements for occupants to remain in the building or the building to be functional for all weather conditions after that designed code level earthquake? Currently, there are no worldwide standards. There's nothing specific in the current building codes regarding performance of the inner workings of all these pieces of equipment and components. What the code is focused on is ensuring the seismic restraint of the equipment and components is adequate so the components don't move from the floor or the wall or the ceiling that they're connected to, but nothing about the actual inner workings due to strong shaking. So in considering, post-earthquake habitability, some of the considerations are, what are the demographics of the building occupants and tenants? Are there any special needs, any vulnerable occupants? That may make the post-earthquake requirements different for each building. Listing out what are the minimum essential needs after an earthquake if all the occupants or tenants want to remain in there. And if so, for how many days? Is it the intent to be self-sufficient if all the public utilities coming into the building are out of service for a certain amount of time? Or can a certain amount of support be relied on from the community? So the next 2 slides are courtesy of BC Housing. We're looking at plans for 5 to 7 days of essential needs for new buildings. And this is regard to maintaining the minimum air quality for occupants, water quantities and quality, thermal control, and the list of references are noted here. Similarly, food and nutrition, means to cook, energy, power, how much power is needed to run various services, communications, and of course, maintaining health and hygiene for the occupants or tenants remaining in that building for a given amount of time. In the past, we talked about a variety of permutations that one may want to do in a new building as far as making it better than code. And on the right is the image about perhaps there's a common area where there's no structural damage and maybe repairable damage in an area up above. So again, what services and essential needs would be necessary to maintain and keep all the occupants and tenants in these spaces after that design level earthquake without having to evacuate and come back in. And again, in the design of a new building, these are some of the things that need to be considered. Power. What are the minimum requirements for cooking, either in those areas of to stay in their units above or in that common area down below? One elevator or all the elevators? The amount of lighting, the amount of heat, the amount of ventilation, all these to meet those minimum defined essential needs for the various different parts of the building. Water. How many days should be stored on site for drinking, cooking, and personal hygiene? Sanitary, if the utilities outside the building no longer function. And again, there's an opportunity in every new building to customize and tailor these requirements for that particular group of tenants or occupants. This is some examples from an owner's contract with the design team to address this post-earthquake habitability and to ensure the design team takes this under consideration in their design. And these are words taken from the actual owner engineering contract. the need for continuing services following an earthquake. The facility will remain operational and usable for its intended functions during and immediately after an event, and a list of essential services to be designed and constructed to post-disaster standards. But however, these services will continue to function post-disaster. So these kind of words can be put into a design requirement to ensure an owner is getting that level of performance from these components and equipment after and during the earthquake. Previously, I talked about FEMA P-58 as a means to assess the seismic performance of the structure, but of course it also can assess the performance of all the building components. So in a design of a new building, one can set target repair times or repair costs for all the different components illustrated in the pie chart. And again, the targets can vary for different systems and services. It's now possible to obtain data on a floor-by-floor basis for groups of components on that floor to define repair times and costs, to that level of granularity. And all this is to enable adjustment of the design of the components, in the early phases of design to suit those performance targets for habitability. On some projects, owners can actually specify that the design team liaise with the future operations and maintenance staff to interpret these FEMA P-58 results, to really demonstrate that the behavior will comply with the performance targets. And this is now a list of some other reference material. If you're interested in reading, as I said, there's no uniform standard. Applied Technology Council in the US about functional recovery time. The US uses the term functional recovery quite a lot. Of course, the goal is not to have to recover, but to actually be able to remain in place and habitable for a defined level of post-earthquake behavior. FEMA, Federal Emergency Management Agency in the US, again, a report here, again, with regards to reoccupancy and functional recovery time, with the goal not to have to reoccupy, that is, not to have to leave and come back to the building, but to have a system designed for both the structural and all the equipment and components to be able to remain occupiable and functional. And finally, Earthquake Engineering Institute, EERI, a magazine they produce, Earthquake Spectra, has another good article on functional recovery. Furthermore, there are standards now to certify the building components and equipment, and this can be done by shake table testing. Again, this is one document, ICCES AC-156. It's cited by the US Building Code, ASCE 7. And again, it's been used extensively over the past 20 years to qualify critical components, on a shake table, subject to the simulated shaking ones expected, because there's different levels of shaking and different heights of the building. So you can actually simulate the shaking expected for the code level earthquake for that component, put it on a shake table, and then verify that will actually function both during and after the earthquake as intended. And a few other standards, perhaps more specific, not necessarily for buildings, but for example, the IEEE for substations that may be applicable if there's some large transformers on a particular project. The NEBS GR63 is another standard that could be used for if there's very specific and critical telecommunications equipment in a building. So again, two other standards to look at if you want really high-level performance of very specific components of the building. And finally, some slides of some shake table testing that has been done in various parts of the world. In Vancouver, you can see at UBC shaking of some electrical equipment, hydro dam, and some bushings in Italy. So there's extensive shake table test facilities in North America and indeed all over the world. And a few other pictures just to show testing for chillers and air coolers and the like in San Diego. So to summarize, building codes, there's currently no detailed requirements for functionality of the inner workings of the components or equipment, nor regarding ongoing operations for each of the three importance levels of buildings that we've discussed in previous sessions. There's currently no go-to national or provincial material. Again, I presented some variety, documentation. There's a lot available for review to customize the habitability goals and performance targets for a specific building. One may want to consider FEMA P-58 methodology to define repair time and repair cost for all these components within a building. Again, at the end of the day, an owner can specify and customize habitability requirements as long as the basic code requirements are met. Again, it can offer language in a contract with a design team to address these and to try and achieve these habitability targets. And again, it can even specify shake table testing for critical components that are essential to operate both during and after an earthquake. So that concludes this session. The next session will be on seismic upgrading of existing buildings. If you would like more information on this topic, please contact me at the email address noted below. For more information on MBAR, there's an email and webpage address noted. Thank you for attending this session, and I hope you join me again for more sessions in this series.